Hello everyone, and welcome back again to the linear algebra component of the Calculus and Linear Algebra series. In the last video we finished off this topic of propositional logic, and in this video what we're going to do is we're going to introduce this idea of first order logic or predicative logic. But before we do that, what I want to do is I want to go back and I want to revisit some of the ideas in propositional logic and discuss some of the shortcomings of propositional logic and why we actually need this higher order form of logic to encompass a wider class of statements that often appear within mathematics. So, going back to propositional logic, one of the things that we noticed is that most propositions generally took the form of describing a particular property about some object. So, for example, I could take something like a banana is yellow. In that situation, the object in the story is the banana and the property is yellow. So, is there a way that I can take statements of that form and I can formalize them within propositional logic? So within propositional logic, can I kind of tell what is the object and what is the variable? Well, the only thing that I've got within propositional logic, or the kind of most fundamental pieces of propositional logic, are the propositional variables. And given a particular propositional variable, there's no way to identify within that propositional variable what is the property and what is the object. I just simply can't do that. I haven't got enough information there to be able to identify those two pieces. And similarly, let's look at other types of propositions that arise. I could take a proposition like every person born in England is a British citizen. Now that contains this word every in, and in fact, anything that contains any statement that contains something like for all or for every, and even further like there exists, I can't actually formalize those statements within propositional logic. Again, like how would I be able to translate this idea of for all into propositional logic? Because I haven't got any variables to run over, because all I've got is just this singular propositional variable, and it doesn't run over anything. It's got no inputs in the propositional variable, right? All its input is effectively the propositions themselves. So first order logic, the whole purpose of it is to address these 2 points. It wants us to kind of create a logic-based system that allows us to identify this idea of property and object, but also allows us to formalize statements that contain things like for all, there exists, or even there exists a unique in them. So we want to be able to kind of formalize statements of that form. And the way in which we do that is, rather than building our structure based off propositions like we did before, we'll actually build them off a different notion known as a predicate. And this is the point where we're going to introduce that now through our definition. So a predicate, much like a proposition, is a declarative sentence, but now it contains one or more variables that becomes a proposition once the values of those variables are known. And we say that the range of values that the variables can take is called the domain of discourse. So in other words, how we want to think of a predicate here is it's kind of like a function, and when I put values into that function, it spits out propositions, and that function can run over many different variables. It could be one variable, could be two, could be n many variables, can be as many as I want. And whatever values I put in to that function, it just gives out a particular proposition. And we'll see how this works in a moment when we kind of look at some more examples, or we'll look at some specific examples of predicates. And just to reiterate again, the domain of discourse is this kind of the set of values, or the range of values over which the variables can run. So in this case, it could be numbers, it could be people, it could be animals, it could be fruits, it could be whatever, but we define that when we describe what our predicate is. So another way, as I kind of said a minute ago, that alternatively we can think of a predicate as a proposition valued function. So when I put in values into it, it gives out a specific proposition, and this is sometimes known as a Boolean function. So otherwise you can also think of this as a function from some variables to the values of true and false. When I put in those particular values for those variables, it either maps to true or it maps to false. So this is quite different to a propositional variable where I put propositions in. Predicates can run over kind of much more general domains of discourse. So now let's move over to our examples of some predicates, and we'll see how that works. So here we have some examples. And our first one that we've got here is going to take x is an integer. And in this story, let's see how this relates to now formalizing our idea of this property and object. So here the variable x is the object and is an integer is the property. So our predicate here is x is an integer. And from that predicate, we can identify what is the property and what is the object. The object is the variable and the property is this statement effectively is an integer. So we've been able to address that. We've been able to formalize that in the context of first order logic. And if I put in particular values of x, so let's say our domain of discourse here was the real numbers, if I put in the number 2 into this, that would be true. Indeed, 2 is an integer. But for example, if I put the value of pi into this, that would be false. So we see when we put in specific values into this predicate, it is either true or false. So this is exactly why I said it's kind of a function. When I put in particular values, it just gives a particular proposition. So if I put in the value 3, that would take this predicate to the proposition 3 is an integer, which indeed is true. So let's look at another one. Here we've got Z is a British citizen, and the variable here, Z, is the object, much like we expected before, and the property is a British citizen. So if we put in, or we have our domain of discourse, let's say all people on Earth, so we can put in any person in there, and let's say I put myself in, so James is a British citizen, that is a true statement. But if you put in, say, I don't know, Boris Johnson, that would also be true, but I should have said something like maybe like Donald Trump. If I put Donald Trump into there, that would be false. So depending on what things I put into this predicate results in either a true proposition or a false proposition, but the important point is that it just maps to a proposition. And the third one here now, we're going to take a predicate that has 2 variables, because I said a predicate can run over many variables, not just one. And in this case, we've got 2 objects. The objects are x and y, and the property is greater than. So we've got x is greater than y. Now I have to put in 2 values here. So let's take our domain of discourse to be the real numbers. And depending on those 2 values that I put in, will give me either a true or false proposition. Again, not so important whether or not it's true or false, but it's more important that it maps to a particular proposition. So if I put in, say, x is 2 and y is 1, then that is going to take this predicate to a true proposition, namely 2 is greater than 1. Or if I put in, say, 1 and 2 the other way around, that would be a false proposition. So it's important in the order in which I put in my values in here. So kind of those are the 2 main pieces, or like that's the main definition of this lecture, to introduce the idea of a predicate, and we've kind of talked about some examples. But what would we do next? Well, the next thing you would normally do, like we did with propositional logic, is you would start to build our logic-based system around this idea of predicates, right? We started initially with propositions, we gave some examples of propositions, and then we built this idea of a propositional variable. That was a variable that took values in the space of propositions. And much like propositional logic, we'll do that with first order logic. We now start with the idea of predicates. We gave some examples of predicates. So the next thing to do is to talk about predicative variables. Well, let's just instantly say what that is. A predicative variable is just a variable that now takes values in the space of predicates, right? So now I've got this space of predicates, and this predicate variable is something that takes values in the space of predicates. And then we want to build a logic-based system around those. Well, we've already done most of the work within propositional logic, because all the logical connectives that were kind of brought up within propositional logic can be brought over now to predicative logic. So for example, now I could take the AND operator, like I had in propositional logic, and bring that over to our predicative logic and take 2 predicative variables and map that to a single predicative variable. So I could have a predicative variable, say p of x, and a predicative variable q of x, and say p of x and q of x maps to a new predicative variable. And this idea, or all these logical connectives that we introduced in the propositional logic part, instantly draw over to this predicative logic part, and we can start proving things about them. So that's actually what we're going to do in the next video. In the next video, we're going to introduce this idea of existential quantifiers and universal quantifiers. So we're going to talk about how to formalize those particular statements that I said at the beginning about how to formalize kind of for all statements and their exist statements. How do those draw over into a formal structure in first order logic, and we'll see that in the next video. So it's very important after this video that you definitely read the notes that are found on the Moodle page, and also to try and attempt any of the questions within the module handbook related to kind of what is a predicate or predicative logic. So thanks again for watching this video, and I'll see you in the next one.